Non-deterministic finite automata by Professor D.T. Kadam. We'll see what is non-deterministic finite automata. A non-deterministic finite automata, that is NFA, has the power to be in a several states at once. This ability is often expressed as an ability to guess something about its input. For instance, when the automaton is used to search for a certain sequence of characters, let's say for example, keyword in a long text string, it is helpful to guess that we are at the beginning of one of those strings and use a sequence of states to do nothing but check that string appears character by character. Nowadays we are using Gmail. We can guess whenever I type thanks and regards comes automatically. So that this is how we can guess the what will be the next move or what is the output. DFA, what is the difference between DFA and NFA? So let's see, before examining the application, we need to define a non-deterministic finite automata and show that each one accepts a language that is also accepted by the DFA. That means both are same in power. Whatever the language accepted by the DFA is same as that of the language accepted by the NFA. So exactly it is, and that language is the regular language. So however, there are no reasons to think about the NFA. They are just often more succinct and the easier to design than the DFAs. Like the DFA, an NFA has a finite set of states, finite set of input symbols, one start state and the set of accepting state. That means definition of DFA is a phi tuple. It is the same as that of the definition of NFA. We can say that means phi tuples, alphabet set, number of states, state transition function, what is the initial state and what will be the what are the final state. It is a set of states. So the only change is the transition function. We can always convert NFA to DFA. Remember that thing. Once we have an NFA for any regular language, we can generate the DFA out of that. So that means they are interconvertible. So the latter may have exponentially more state than the NFA. Fortunately, case of these types are very rare. In the worst case, smallest DFA can have 2 raised to n for the smallest NFA with the n state. This is what the relation. If we have a designed NFA having n state, then how many states can be there in the DFA? We can say it may be 2 raised to n. Now, few more only thing in the chain DFA and NFA, it has also a transition function which we shall commonly call as a delta. The difference between the DFA and NFA is in the type of delta. That means only change in the DFA and NFA is a transition function, delta. For NFA, delta is a function that takes a state and input symbol as an argument, like DFA transition function, but returns set of 0 more 1 or more states rather than returning exactly one state as we have seen in the DFA. DFA returns only one state, whereas NFA returns 0, 1 or more states. That is a big difference, or this is what the main thing or that is the main point is only different than that of the DFA. So let's see the definition of DFA. As we said, it is the same as that of the definition of NFA is same as that of the DFA. It is a phi tuple Q, sigma, delta, Q0 and F, where Q is a finite set of states, sigma is finite set of input symbols or input alphabet set, delta is the transition function, where at a particular state after reading particular symbol you may get the 0 here maximum. I have written here maximum states. Here it may be 0 or 1 or maximum we can say 2 raised to k, like this. So no states also be that means you remain to the same state. Only one state you will get as output, or any number of states, multiple choices we can achieve. Maximum multiple choices may be 2 to the power x, or I can say power set of a q, where q0 it is a start state and it is a subset of the q, or I can say it belongs to the q, whereas f is a subset of a q. It is a set of final state, or we can say set of accepting states. Let's take one example where we can use NFA. Why to choose the NFA? Let's say one example, machine having the language L of M is equal to W, such that W belongs to 0 and 1, which accept the string that ends in a 0, 1. So how to define this NFA? How many states are there? What will be the definition of that? So in this case, if I am at a state q0 and if I says what is my motive? Once I see 0, 1, the strings ends with a 0. So I may once I get the 0, I will change the state. And in hope that in the next I will read the 1. So once I read the 1, I will get the final state and expected output. But sometime there may be in this case there is only before that any number of zeros and 1 may be there, right? So I have choices. If I have at 0, I may go to the q1, or I may remain in the q0 only instead of going to the q1. So to solve such problems, we will using the we are using the NFS. So this is what the transition diagram, and based on transition diagram we can draw the transition matrix. How to draw the transition matrix? The columns are alphabet set. Here alphabet set is 0 and 1. That will be our columns. What are the states here? Q0, Q1, Q2. That will be the rows. So here see the diagram. Diagram can be converted into the graph or matrix. Sorry. So Q0 on 0. Here I may remain in the same state, or I may switch to the Q1. So this is the set. So here in the matrix, this cell is a set. It is not a single element like the DFA, but here it is set of element. So we will get either Q0 or Q1. On 1, we will be in the Q0 only. In the Q1, on 0, nothing is there. So it is empty set. Nothing is there because set containing nothing is an empty set. That's why we are writing here 5. If I read 1 in the Q1, so I will accept the string. So I will be in the accepting state, that is the Q2. And here finally Q2, on reading 0 and 1, nothing is there. We can just write the empty set or 5. Now arrow pointing start state is here Q0, so pointed by the arrow. Q2 is the final state, pointed by the star. So here see the explanation in more detail. States in the NFA during the processing of the input sequence. Say example 00101 is the string. So how it is handled by the DFA. Initially at a Q0, after reading 0 first string, I may go to the Q1 at a first glance, or I may remain in the Q0 only. So again I read 0. Same thing in the Q0, I may remain in the Q0, I may go to the Q1. Now in the next string I read is 1. Symbol from the string is 1. So here Q0 on 1, we are going to Q0. I may go into the Q1, and Q1 I get to the Q2. Now here we stuck, right? Now next, again one more string I have to read, but nothing is mentioned over again here. So I will follow this path only. Now I read symbol 0. So again same, if I may remain in the Q0, I may go to the Q1. I have two choices. I have guessed two things. Now in next one is the, I will read the last symbol of the string, that is 1. So Q0 on reading 1 may remain in the Q0, or Q1 may go to the Q2. Now, as here we have multiple paths, out of that, if any one of them reaches to the final state, then the string is accepted. Now, here in this case, this route from Q0 to Q2 is selected, which is reaching to the final state, and hence the string 00101 is accepted. So last one, what is the language of NFA? As we said, both are the same in the power. DFA and NFA are equivalent in the power. That means whatever the language generated by DFA is same as that of the language of NFA. We know that a regular language is generated by the DFA. So here NFA also generate same language called as a regular language. So how to define that? This is what the your NFA language denoted by L of A. Then it is defined like, it is a set of string containing such that the extended transition function Q0 on W is intersection with the F not phi. That means if your string belongs to the language or one of the path reaches to the final state, then it is accepted by the NFA. And the language of A, set A, is a set of string W which belongs to the alphabet set, such that extended transition function contain at least one accepting state. Or in the same definition can be written in the words form. A language L is accepted by some DFA is only if L is accepted by some NFA. As we said that by the definition, both the languages, that means DFA and NFA, generate same regular language. References: this is the book I have read for this topic.